Wait, did I send you the first sentence that I wrote with the physical properties of iron? Because if so, I'm gonna have to rewrite the whole thing.
No, I don't have it. I suggested hanging on to it for the next lesson. Um, you may have it like on your chat, your side, but you may just have to rewrite it.
Yeah, I have to rewrite it because I wish chat history from previous Zooms show up so I could see what I was writing, but no, I have to rewrite it. Sorry, give me a second. My mom's just asking me
Sure,
something, so
sure, take your time.
I should mention how magnets with iron are used in like daily or
I would
like
go to the internet and just look for some uses of magnets out there. Common
right.
uses of magnets.
All right. I just typed something in the chat.
But physical properties of iron are it being magnetic and dissolved into dilute acids. Some common use of magnets are compasses and fridge magnets. Good. Okay, I think that will be acceptable. So let's go ahead and like I mentioned, let's get rid of this table and add that in there. Okay, we're moving on here to the next one where there's feedback. So all the way down to question 7. Question 7 on the way down here. All right. So it says here, your teacher was, can you find the molecule in this lesson above and question and turn this? Okay. All right. So let's go. This is what your teacher is saying. Can you find Can you find the molecule in this lesson? So I guess we got to go to the lesson, which I'm doing now, and I'll see if we can just get right to it. All right, so let me grab the molecules here. I'm going to snip this in. All right, here we go. Okay, so biological molecules. All right, and there are three types of biological molecules. There's proteins, carbohydrates, and lipids. Okay, and then hydrocarbon molecules are they're made entirely of carbon and hydrogen. They talk about them being found in crude oil, and then there's these long chain molecules called polymers, plastics, and synthetic fibers. Okay. Um, so I think what they're asking you is like which molecule, which molecule, yeah, which one would be a good choice for cartilage and tendons, I guess. Uh, I'm a little lost. I mean, I don't understand how these are related, but let me do a quick search on this. See if I can find out more about what they're looking for. Right. So I think for the third question, we did say that fats are, and we talked about lipids. If you remember, we I think we talk about that. Um, so I think we need to say like which one is cartilage and tendons, and I think the best answer here is protein. If you read here, it says that they provide stiffness and rigidity. Does that
Yeah.
so maybe just throw in that word here, proteins, protein. Do you want us to add more to it than that? Or just put the word there? What do you think? Is this okay, or do you want to dress it up a little bit with more words?
Yeah, that's okay.
All right. So let's look at number two here. So gasoline. So gasoline is combustible. So it's a hydrocarbon. Many hydrocarbons are combustible. So we'll just say that hydrocarbon, period, like that. Okay, that takes care of that. The next question that your teacher had issue with is 9 through 13.
you want me to write something again?
No, let me try to make some sense of this. They want you for the next one that she wants you to cite your sources. Um, for 9 through 13. So let's go look at 9 through 13. All right. Yeah. So do you think a link would be sufficient, or do you think your teacher will want you to do like the full like MLA APA citation?
I think I think a link will be good.
Okay. So one of the things I do is I always, keep my history. You might be able to search your history for this.
I mean,
Um, but why don't you drop a link in for 9 and
let me go. I should find a link for the pure metal aluminum. Okay, I found a link that could work for number 9 about
okay.
aluminum.
All right, so let me do the right thing here. This is a Google link. This is not going to be acceptable. You want to go to like even if it's not the one you used, you don't want to just give a Google search link. That looks bad. Wait
All
a
right.
second here. Maybe you.
Maybe I
Okay.
accidentally copied it incorrectly. One second. Let me
No,
just.
I mean I see where you're looking here. This doesn't have the history of aluminum. So this is what you sent me is more of the just the like the general information on aluminum. You want to find something on that two-stage process of aluminum.
Gotcha. Man, I'm struggling to find the link because,
It's okay to find a new one. Um,
yeah, because it showed up the last time.
let me do this. Let me copy this into the chat, and maybe that will help you with what you're searching for. And I'm only pushing back because if the instructor clicks on the link, they're going to say the same thing I did, which is well, it's not really.
Yeah, what you typed me in chat, I found that through I wish I copied the website, man. They would have been so helpful. And now it doesn't want to show up anymore. Maybe if I just maybe if I copy and paste it what I paraphrase, it's gonna show up. All right, let's see. It's showing up on Wikipedia, so I guess it's from. I found a link from Britannica about the
Yeah,
processing, I think.
that's good. That see, and I don't even have to look because that Britannica. I'm not concerned that that's a bad link. Okay, now we're up to copper. Copper. Maybe you go to Britannica. I mean, I don't want you to just use Britannica, but that would be, if that were the if that were a thing there. But go ahead and just maybe find and I'll just copy this in the chat again for you.
I found a link explaining to why, for our answer, you know how we said copper is used in wires throughout homes and stuff? I found a link that explains why it's good for that,
That's
so we
fine.
could use
Yeah, that's good enough.
that. Yeah, there we go.
All right. That's fine. Okay. So let's go to the next one here. Um, the most common uses of gold. Drop that in the chat.
All right, I found something with Britannica that
All
works for
right,
gold.
probably okay. We can't use any more on that. It gives the sense that you're just going there the whole time, which may not. We'll see what they say. But you've got a couple more here to do. I don't remember how far up to go to. Yeah, all the way up to 13. So you're gonna have to keep going here. The most common use is metal magnesium. So for future assignments, we'll just have to remember that it's really important that you grab the link and
All right, I found a link for question 12.
okay. Yeah, that's let me copy that. So the other thing that maybe we should be doing, and just I don't know why I should just think of this, but we maybe there was a link in the lesson. It's always good. I mean, there's nothing wrong with this where you're sending me, but uh that would also have been an option here. So let's last one here. Oops, that's the wrong one. I guess you don't have to do it for 14. All right. Oh, that's because of a different question. All right. Most common use of metal osmium and metal osmium. So I'll drop that in the chat.
All right, I found a link for number 13.
All right. So for The next one here that we ran into issues with, it says for question 14, we're looking for the fourth period, row equals period. So we need to go back to the periodic table and look at the fourth row. So let me go grab the periodic table from your lesson. Which I'm not finding. That's okay. All right, so let's look at the fourth period, fourth row. So hydrogen and helium are in the first row, then lithium, beryllium, and so on. That's the third, that's the fourth. So we probably should stick with stuff that we know instead of stuff that we don't know. Like titanium, iron, nickel, copper, zinc. Any of those stand out to you as maybe being
I'm sorry, repeat that like one more
well,
time.
trying to not just give you the answer. Is there any of those that seem like they might not react with water?
Hmm.
So you could do a quick search. You could say, does iron react with water? Does titanium react with water? And I think you'll find most of these metals do, along with potassium and calcium. So you're kind of looking over here on the right. You
I
might
feel
try
like I
like
know
the,
the answer. I,
okay, what is the answer?
I'm not sure. I feel it. I know in my head. I know it. I just can't. It's on the tip of my tongue, so I have to search it up.
Okay.
I've heard this before. I feel like I know it. That's the thing. Copper? Does copper re not react with water?
Go ahead and do a quick internet search on that. Yeah, just
It
search like
says
copper react with water.
okay. It says here that kind of searched it up before I answered, but I didn't look at it. It says here that metals such as lead, copper, silver, and gold do not react with water at all.
Right. So copper's one. What else?
It says here gold,
It's got to be in the fourth row.
the fourth row. Okay.
Copper's in the fourth row. So that's good. So you've got a bunch here that you can look look for. You've got copper.
All right. Let me see if iron reacts with water. It says iron doesn't react with water.
Okay, so there you go. You got two then. Iron and copper. All right. Okay, so the next one on your list here that needs a revision is 16. Try this one again. Which metal is molten or can melt on a hot day? So the answer is gallium. So we'll just switch to gallium. All right. That is all of the revisions for this one. What would you like us to do next with the time we have left?
I have to search up more metals.
Oh no, that's the answer. That's it. We're all good.
Okay.
No, I mean, it's just, we'll just say gallium. That's it.
All right.
Sometimes I don't change the answers because I don't think there's a reason. I mean, I just assume your teacher wouldn't push back on one wrong answer, but in this case, the teacher wanted a lot of changes. So give you that last one. So kind of think about like, what do you want to work on tomorrow? We can just start looking at it. It will be early, 9 a.m., 10 a.m. Uh,
Oh yeah.
but we've got 2 days in a row.
We could look at it. I think, yeah.
Which class do you want us to look at next?
Let's do some physical science.
All right, so I think we're up to lesson 8.
Yeah.
Does
If
that
it's
seem
a
right to you?
lab, then we're gonna have to wait till I get home.
All right. So I'm concerned about what your teacher will accept here. But we can do this. Yeah. So let me open up a new Word document here, and we'll look at lesson 8. And a lot of this is just basic chemistry, so you will be not overwhelmed. All right, let me pull up question 1. All right, for each of the following, predict the chemical formula of the binary. Oh, you're not seeing that. Let's share your share screen. All right. For each of the following, predict the chemical formula of the binary ionic compound they form. Show all your steps as we did in the examples above. That's where I'm unsure if that's going to be okay. Using either the method in examples 1 and 2 or the crisscross method, and check to make sure the charge is balanced. Name each compound. Some of the names are given. Okay. All right. Yeah, there's like a lot here. Um, so I don't really know why they want you to go to all this trouble, but the I'm sorry, lead 2 means lead is +2, and iodide. Could you look up the charge on iodide? The reason I know that lead is 2 is because of that Roman numeral there. So tell me which column iodide is in the periodic table.
I still don't get it.
I'm just asking you to look up iodide in the periodic table. Just tell me where
All
it
right.
is. Periodic table.
On the
Which
periodic
column is it in?
table? All
Yep.
right, let me go. I am so happy when you send me that website with this periodic table. It's way easier to find things.
Yes.
Okay, that's number 53 in the
Okay,
periodic table.
which column is it in?
It's in column um, 5.
How did you come up with
Hmm?
how did you
I'm
come
sorry,
up
what?
with column 5?
Well, I so I searched it up on the periodic table and it showed up, and like, so when I put my cursor on iodine, uh it showed where number, because on, I know on the top it has a number of atomic charges, I think, or something like, but the columns are like down, and so I just looked down at iodine, and then I looked at the number, and it showed number 5. And I
So
hit
that this is the first column. This is the second column, and then the third is like all of this, but then boron is the
Oh,
fourth, fifth, and so on. But um
oh, my
the column
bad.
really doesn't what that doesn't really matter. What I need you to know about iodide is that it wants to gain one more electron. That's what I was really looking for. I don't need the column.
Oh,
Iodide wants to gain one electron, so that makes it -1. Okay. So if we
okay.
wanted this to have a net 0 charge, okay, lead is +2 and iodide is -1, does it currently have a net 0 charge? Basically, I'm asking you what is +2 -1?
+2 -1 is +1.
Right. So that's not net 0. So how can we get this to 0? How many iodides do you need?
We need, um,
So if you have 2 of them, does that make a -2 charge?
no. Wait.
Isn't 2 times -1 -2?
Yeah, sorry, my bad. I was like,
Okay.
wait a second, why did I say no? I was
Okay.
rethinking it.
Okay. So the net charge is +2 -2, which equals 0. So that's what I believe they're looking for here. So what I need you to do is look up potassium and decide like what it is. Is it a +1? Is it a -1? A +2? A -2? What is potassium?
Gotcha.
Does it want to lose or gain an electron?
Okay, potassium is number 19 on the chart, but it's number 19, but in column 1, it's
Okay.
positive,
So,
right?
well, is it +1, +2, +3?
Where do you go check for the +1 or +2? That's energy levels.
So as a reminder here, anything in the first column wants to lose one electron, wants to lose one. So that becomes a +1. Second column is
Okay.
a +2. Over here, boron, this is +3.
So it's a +1,
Yeah,
because it's
carbon is
in.
either carbon column is +1 or +4 or -4. Once you get over to nitrogen, it's -3. Oxygen is -2. Fluorine, all this is -1. Okay, so it's a +1. So what's the letter for potassium?
Mm. Isn't iodine also just like, it's the same as the top, it's a -1.
It's a -1. So what is the net charge?
0.
Net means yeah, after you combine them together, yeah. So you're all good there. All right. Next, you're gonna look up calcium. So look up
All right.
calcium and chlorine. We're gonna do the same thing.
All right. Conveniently, calcium, it's the first thing that popped up, and it's in column number 2.
Okay, so what is it? What is it in terms of positive and negative? And what's the 2 letters for it? Or
You
one
said in
letter.
column 2, um it's gonna be +2.
Okay, so what are the 2 letters for that?
For calcium, it is Ca.
Okay, you do the same thing for chlorine.
Chlorine is Cl, and it's in column. What was it called? Column number. It's in the same column as iodine, so that means it's a -1
Okay.
charge.
So what is its current net charge when you just look at these two?
It's gonna be a +1.
Okay, so how do we get it to zero? Which one do we need more of? The Ca or the Cl?
The Cl.
Cl, yeah. So we need two of them, one of those. The net charge is now +2 -2, which equals 0. All right, let's keep going here with lithium and oxygen. Do the same thing. Or we can stop here. Pick
Let's
up here
just do
tomorrow.
the lithium and oxygen and then we'll stop.
Okay, so real quick here.
Lithium is number 3. It's in column 1. Says a +1 charge. The
Okay,
lithium numbers are Li. And now oxygen. Oxygen is it is it's numbers 8, but I don't know, is it also a -1?
it's not
Or am I
is it in the same column as iodide?
No,
Iodine,
so it's a -2.
-2. There you go. So you need two lithiums to go with one oxygen, and there's your net charge.
Got it.
All
And
right, so we're
perfect
gonna stop.
timing.
Yeah, we're gonna stop there for today. So I'll send over all these files and we'll just pick up here tomorrow at 9 a.m.
All right.
Thank you.
Thank you.